In this video, we are going to learn about the enthalpy of a chemical reaction and how it can be used in stoichiometric calculations. A reaction that absorbs heat from the surroundings is called endothermic, while a reaction that releases heat from the surroundings is called exothermic. Chemical reactions often involve the absorption or release of heat. The change in enthalpy, symbolized by delta H, is the amount of energy absorbed or released by a chemical reaction at constant pressure. You can think of enthalpy as the flow of heat during a reaction. The sign of delta H, whether it's positive or negative, depends on the direction of energy flow. Endothermic reactions our delta H is positive because energy is absorbed from the surroundings. For exothermic reactions, our delta H is negative because energy is released to the surroundings. In an exothermic reaction, the reactants have a higher potential energy than the products. As the reaction proceeds, the reactants release this excess energy to the surroundings. Because the surroundings receive heat, they become warmer. A familiar example is fire. You can feel the heat coming off of this reaction because the energy released by the reaction flows into the surrounding air. Another example is aerobic respiration, in which glucose reacts with oxygen to produce carbon dioxide in water while releasing energy in the form of heat. That is the chemical reaction that happens as you breathe. An endothermic reaction absorbs energy from the surroundings. The reactants begin with a lower potential energy than the products, and they must absorb energy in order for the reaction to occur. A common example is photosynthesis, where plants use sunlight as the energy source needed to convert carbon dioxide and water into glucose and oxygen. Notice that photosynthesis and aerobic respiration are the same overall chemical reaction, just written in opposite directions. Aerobic respiration has a negative delta H because it releases energy. Photosynthesis has a positive delta H because it absorbs energy. Determine whether each reaction is endothermic or exothermic. Here's our first example. N2 plus 3H2 produces 2NH3. Delta H is negative 92 kilojoules. Because delta H is negative, this reaction is exothermic. Our second example is calcium carbonate produces CaO, calcium oxide, plus carbon dioxide gas. Delta H is positive 556 kilojoules. Because delta H is positive, this reaction is endothermic. For our last example, we have 2SO2 gas plus O2 gas produces 2SO3 gas plus heat. Since heat appears on the product side, this reaction released heat and is therefore exothermic. The enthalpy of a reaction is proportional to the stoichiometric coefficients in the balanced chemical equation. Previously, we used stoichiometric coefficients to create molar ratios between substances. Now we will use one stoichiometric coefficient together with the delta H value in order to create conversion factors between moles and kilojoules. Consider the combustion of propane. C3H8 plus 5O2 produces 3CO2 plus 4H2O, with a delta H of negative 2044 kilojoules. From this, we can write several equivalent conversion factors. 1 mole C3H8 is equal to negative 2044 kilojoules. 5 moles of O2 is equivalent to negative 2044 kilojoules. or 3 moles of CO2 is equivalent to negative 2044 kilojoules. Any reactant or product can be used to create an appropriate conversion factor. Let's do a practice problem. If 15.0 grams of NO is produced, how many kilojoules are absorbed? The balanced equation is N2 gas plus O2 gas produces 2 NO gas, and the enthalpy of the reaction is positive 181 kilojoules. Since the question gives us grams of NO and asks for kilojoules, we will first need to convert from grams of NO into moles of NO using the molar mass. Then, from the balanced chemical equation, we know that 2 moles of NO is equivalent to 181 kilojoules. Our calculation proceeds as follows. We first need to convert from grams of NO to moles of NO using the molar mass. Then we will convert from moles of NO to kilojoules using the enthalpy as a conversion factor. The end result is 45.2 kilojoules. Let's do another practice problem. How many grams of O2 react if 1,280 kilojoules of energy is released during the combustion of methane? The balanced chemical equation is CH4 plus 2O2 produces CO2 plus 2H2O. The enthalpy of the reaction is negative 890 kilojoules. Although the problem states that 1,280 kilojoules is released, the word released tells us that the energy change is negative. Therefore, the given value is negative 1,280 kilojoules. Use the reaction enthalpy to convert from kilojoules into moles of O2. Then use the molar mass of oxygen gas to convert from moles of O2 into grams of O2. Remember that masses cannot be negative. If you obtain a negative mass, it is a sign that you have mishandled the negative sign in your calculation, and you should double check your work.